so we're going to deal with word problem in this section. So I'm going to walk you through on how to solve a word problem. Okay. So the first example I have is this right here. It says a rocket propels straight up with a launch velocity of 160 feet per second and about 109 miles per hour. It reaches a height of s equals 160t minus 16t squared feet after t seconds. So I have to point this out. In word problems, they like to do this thing called a distractor. A distractor basically means numbers that they put in that you will not use in the word problem, but they like to throw that in. So in this case, we do have a distractor, which is the 109 miles per hour. It has nothing to do with the word problem. They just put it in there and don't let that distract you, okay? So what we're working with is then the S equation. The equation that we want to work with is 160t minus 16t squared. Let's make an observation with this right here, the equation. I notice that this is a t squared, meaning that it's a parabola shape, right? I also notice that this is a negative in front of it, which means it's an upside down parabola. Good. So that means this right here is an upside down parabola right here that we're dealing with, okay? So the rocket is going to do stuff with this upside down parabola. Let me let the rocket do its thing here. So it's moving up, and then it's going to come back down and land. So then let's go ahead and do part A. Part A says, how high does the rocket go? So we want to find out is the maximum height of this rocket. But before we do that, we need to find out is the maximum time of this rocket. Okay? To find maximum time, I'm going to take the first derivative of the S equation right here. And so that gives me the 160t gives me 160. And then this is 16t squared gives me 32t right there. Okay? Now, also notice this right here, if I take the first derivative, I'm going to have is one variable of t right there, right? In Algebra 2 and also in pre-calculus, we learned if you have t squared, you have a possibility of two solutions. But I only need one solution in this case because I'm looking for is t maximum right there, okay? So if you take the first derivative, that leaves me at t. So we're going to solve for this, which means that we're going to have to set this equal to 0 and solve for it. So I'm bringing the 160 over on the other side of the equal sign, gives me negative 160. We're left with negative 32. So we're going to bring that over on the other side and give me 5 seconds. So it means at 5 seconds, this is where it's going to reach the maximum. But that doesn't answer my question because the question is asking is how high does it go? So we're actually looking for is the y value right here, the y maximum. So we need to figure out what y maximum is. Okay? To figure out y maximum, I'm going to use the original equation because this is the parabola equation. That's the only equation that I have to figure out what the y maximum is. So I'm going to rename the S with the y maximum right here. Using the 160, I'm substituting in 5 for the t seconds right there because remember that was the 5 seconds. If we calculate this out, we're going to get 400 feet. So it means that at 5 seconds, the maximum time is going to reach a maximum height of 400 feet. Okay, let's move on to part B. So part B says, what is the velocity and speed of the rocket when it is 256 feet above the ground on the way up and then on the way down? So I probably need a 256 line right there. Now, graphically, this is y equals 256, right? And also this is an S equation right here that we mentioned in the last part right there. So that means there are two intersections, an intersection right here and also intersection right there, graphically. Right? So I'm going to call this T up because the rocket's going to go up, intersect it right there. It's going to reach its maximum and then come back down. And I'm going to call this T down right there because it's going to come back and intersect it again once more. Okay? So we're going to take the original equation, which is S right here. And I'm looking for two t's, right? The solutions. I'm looking for two solutions. So I'm going to keep this right here, my t squared right there, because that's going to give me two solutions. But I'm also going to set it equal to 256 because we're trying to figure out is when do they intersect. Okay? So I don't like to deal with negative 16t squared, so I'm going to bring this over on the other side of the equal sign, leaving me at positive 16t squared minus 160t plus 256. Okay? I'm also going to notice that I can factor out a 16, so I'm going to factor out a 16 from this equation right there. And I think this is small enough that we could probably do a binomial factoring. So let's go ahead and do a binomial factoring, leaving me at t minus 2 and t minus 8. Let me just check this to make sure it's right. So this is negative 8 right there, right? This is negative 2 right there. So that gives me a negative 10 when I add them up together. And this is negative 2 times negative 8 gives me positive 16. So it works. Okay? So we're going to set each of these parentheses equal to 0, and that leaves me at t equals 2, and then t equals 8 seconds. So at the t time up, that's 2 seconds, it intersects at 256. It's going to reach its maximum, then come back down at 8 seconds. It's going to hit at 256 again. Okay? But the question's asking us to find the velocity. So velocity is the first derivative of s. So that's going to give me then 160, right, minus 32t from the s equation right there. Okay? So I'm going to substitute in my 2 and my 8 into this velocity to figure out what is the velocity at those times. So at 2 seconds, the velocity is 96 feet per second. Notice the units right there. And then also at 8 seconds, it's going to be negative 96 feet per second. Notice this is negative. Why is it negative? Right, so when the rocket goes up and hits a maximum, basically it's going to fall down, it's going to go towards the negative on the y-axis right there. So that's going to give us the negative, okay? All right, next the speed. So the last part was asking us to find speed, and the formula for speed is the absolute value of velocity. So that gives us 96 feet per second. All right, part C. So part C is asking us what is the acceleration of the rocket at any time t during its flight. So I'm using my original equation, which is s equals 160t minus 16t squared. And we mentioned in the last problem that we took the velocity. So velocity is first derivative of s. So I get 160 from this right here, and then I take the first derivative, 16t squared, that gives me negative 32t, okay? To find acceleration, I need to take another derivative of velocity. So derivative of velocity is acceleration, which is negative 32. Notice there is no t right there because the derivative 160 is constant, so that disappears, and this right here becomes then negative 32 right there. Okay, so we're just going to add the units, which is then negative 32 feet per second squared. So if they ask us to find acceleration at a certain time, t equals, let's say 5, we will not substitute in 5 into this equation. Why? Right, because there is no t variable in here. Okay, so acceleration will always be negative 32 no matter where the location is. Alright, and then let me also show you some tricks on how to remember this, because a lot of times students, they get confused, is when do I take first derivative, what does that give me, and second derivative, what does that give me, or where is acceleration and where is velocity, etc. So when we talk about acceleration and velocity, we're talking about movements, right? So I'm going to say that in Spanish, when we move, it's va, right? So we're going to say that se va right there, okay? So se va means that s is the original equation, va, the v is going to give me velocity, and then a is the acceleration. So that way you'll remember that first derivative is velocity, second derivative is acceleration. All right, let's do part D. Part D is asking us, when does the rocket hit the ground? So in our perfect calculus world, or I'm sorry, in our part A, we mentioned about how t maximum right there is 5 seconds right there, right? And so in our perfect calculus world, it's symmetrical. If it went from 0 to 5 seconds to get to the maximum, right, to get to the landing part of it, right there, you would have to take then 10 seconds right there. Okay? So these are the types of word problems that we're going to work with in this section. So let's go ahead and do some of these on the homework.